Hello everyone. I will quickly introduce the MarS open source project. MarS is a financial market simulation engine powered by a generative foundation model. We've released our LMM order model, along with 3 powerful analytical tools: Stylized Facts Report, Market Forecast, and Market Impact Analysis. We will demonstrate these tools in detail later. This is a high-level overview diagram illustrating the core components, workflow, and potential applications of the MarS simulation engine. We provide simple installation instructions and a comprehensive market simulation library called MLlib, allowing users to focus on the design of states and agents. Now, let me introduce our model page on Hugging Face. Our MarS order model is available for download and use here. Here we provide a quick start guide, including installation, loading the model, and configuring converters. We encourage everyone to try MarS and get more information through our GitHub repository and Hugging Face page. Now, let's move on to the interactive demonstrations. We've developed 3 interactive tools that showcase what MarS can do. We begin with the Market Forecast tool. The core idea here isn't about predicting a single future price point, but rather using our large market model to simulate a distribution of plausible future market paths. On the left, we configure the simulation. We set the start time and duration, the number of rollouts, which means how many independent simulations will run. You'll also see an initial phase duration. During this initial period, we use a basic noise agent to establish a starting market condition. The main chart visualizes the results from all the simulation runs. The central blue line shows the median price trajectory derived from all the rollouts. The shaded blue area represents the standard deviation, giving us a visual sense of the forecast's uncertainty or the range of potential outcomes. The dots indicate which simulation agent was primarily active, the init agent for the setup phase, and then the BG agent, our background agent powered by the LMM, which generates the core forecast based on the evolving market state. This tool uses the generative power of the LMM to explore a spectrum of market possibilities, providing a richer view than a single-point forecast. Note that achieving high fidelity requires good quality initial data and sufficient computational resources to run an adequate number of rollouts. Next, let's explore the Market Impact Analysis tool. This is designed to address what-if questions. Specifically, how might a proposed trading strategy influence market prices and liquidity? The setup here is similar to the forecast tool, but includes a key parameter: the volume ratio slider. This determines the intensity of the trading strategy we want to test. In this demonstration, it's a time-weighted average price buying strategy, relative to the market's typical volume. The results panel provides 2 perspectives. Trading progress. This chart monitors how effectively our simulated TWAP agent executes its orders. The green line tracks the cumulative volume traded against the target volume, shown by the dashed orange line. Price impact. This is the core analysis. It overlays 2 scenarios: the simulated market price without our strategy active, and the price with our strategy running. The divergence between these lines visually represents the estimated price impact of our trading activity. By comparing the outcomes, specifically the price paths, we can isolate the impact. The background LMM simulates how other market participants might react to the strategy's orders. MarS enables controlled, simulation-based experiments to estimate market impact, offering insights without incurring real-world trading costs or risks. Finally, let's touch upon the Stylized Facts Report. It serves a critical validation purpose, assessing the realism of our simulation engine. Financial markets exhibit consistent statistical characteristics, often called stylized facts. Think of properties like heavy tails in return distributions, meaning extreme price moves happen more often than a simple normal distribution would predict, or volatility clustering, where periods of high and low market turbulence tend to group together. This tool provides quantitative evidence that our simulation engine captures the essential statistical texture of real financial markets, building confidence in its outputs. Performing this analysis requires access to appropriate historical order level data for the market being simulated. In summary, these three tools highlight how MarS can be applied for predictive exploration, strategy assessment, and rigorous validation. They represent a powerful, simulation-driven approach to financial market analysis, grounded in generative AI. Thank you.